using the graph of f of x equals 2 to the x, sketch the graphs of g of x equals 2 to the x plus 3, h of x equals 2 to the minus x, p of x equals minus 2 to the x, and r of x equals 2 to the x minus 4. So we're looking at transformation, so it would probably be quite useful to start with this f of x equals 2 to the x. Well, if you think about it, a key point of interest, the y-intercept happens when x equals 0. So if x is 0, y is 2 to the 0, which is 1. So when x is 0, y is 1. So it goes through 0, 1. Then when x is 1, well, y would be 2 to the power 1, which would be 2. So it's going to go through 0, 1, and 1, 2, like that. 1, 2. And then after that, well, it's going to get quite big. So anything 2, so 2 cubed, or 2 squared is going to go up to 4, then 2 cubed is going to be 9, and so on. And by the time you get 2 to the power of 4, you're already on 16, and it's just going to get bigger and bigger and bigger. So this function this way, it's just going to kind of go up like this. Get bigger and bigger and bigger and bigger. Then the other way, well, you're into sort of negative x's. So say 2 to the power minus 1 would be minus 1 over 2 is reciprocal of 2 to the power 1. So it's going to go through, say, minus 1.5. 2 to the power minus 2 is going to be minus, so it's going to be 1/2 to the power 2, which is a quarter. So it's going to go through minus 2.25, and so it's going to go through minus 3 1/8, minus 4 1/16. I guess it's getting really, really close to 0. So what happens here, as you go negative in the x's, the y's get smaller and smaller and smaller, but they never quite get to 0, because even if you get really big negative x's, when we raise 2 to the power of them, it will not generate a negative output for a negative input. So this is f of x equals 2 to the power x. Right, so now we just need the rest. We've not been asked to state, I've not written it on here, but what I want to do is I want to state the domain, the range, and the equation of the horizontal asymptote for all of these graphs. So it'd probably be useful if I had it for this. So the domain, well, any real number can go into this. X is going to go all the way to minus infinity that way and infinity that way, so it's just x. So the domain is, well, x is just a real number. The range, well, you've got this horizontal asymptote at y equals 0, but anything beyond that. So basically the range is y needs to be greater than 0. And the horizontal asymptote is at y equals 0. So asymptote is y equals 0. So I want to do this for all 4 of those, and we're going to use this as the parent function, and we're going to think in terms of transformations. Right, so hopefully we'll fit them all on. So we will start with b. So if f of x equals 2 to the x, well then 2 to the minus x, just think the f, the function bit, is to take 2 and raise it to the power of the input. If we raise it to the negative power of the input, that means we're timesing the input by minus 1 before we put it in. So this is f of minus x. So that means that h of x is f of minus x. Now f of minus x means reflection in y axis. So that's what we need to do. We need to take this as the parent function and reflect it in the y axis. So I'll try and fit it in here because I know I'm going to need more room for some of the others. So let's go down there. So it's still going to go through 0, 1 like that, 0 and 1, and it's going to go, instead of going through 1, 2, it's going to go through minus 1, 2, because when you're reflecting the y-axis, you're going to reverse the sign of the x coordinates. So This is going to be kind of minus 1, 2 up here, and then everything else, well, it's going to go, it'd be a lot easier to reflect it on the graph actually, but basically this bit's going to be reflected up here, and this bit's going to come down here. So it's going to end up doing something like that. Okay, this is h of x equals 2 to the minus x. So again, I want domain, range, and horizontal asymptote. And actually, the domain and the range are no different. We've still got x can be any real number. We'll give an output there. So x can take any real number you can think of, and there will be no issues. It's natural domain. So domain is x is a real number. Range, we've still got this horizontal asymptote, which is the same at y equals 0. We'll write that down in a minute. So the range is y needs to be greater than 0, and as I've just said, horizontal asymptote is going to be y equal 0 again. So if we move on to part C, we now have minus 2 to the power x. Just realized I completely skipped A. Can I tell you what? I'll try and get A in here. Not my finest video. So let's do, well, if f of x equals 2 to the x, well, 2 to the x and then add 3, it must be f of x. So we do the whole of f of x and then we add 3. So that is a translation. I know it's a translation because it's adding, and I know it's outside of the bracket, so it's vertical, so it does exactly what I probably think it would. So this is a translation, doesn't go across at all, and it goes 3 up. So basically everything on this needs to stay the same, except it needs to go 3 spaces up. So this 0, 1 is going to be 0, 3. This 1, 2 is going to be 1, 5, and so on. So if I draw the axes, something like that, it's not going to necessarily have the same scale, but the other thing that's going to shift up 3 is this asymptote. Really important. Once we add 3 on, the horizontal asymptote is going to be y equals 3, so I'm going to draw that in. So hopefully once I've got that, you can kind of scale everything from that. So this is y equals 3. And then you can kind of, well, it's 0, 1, as it's just going to be 1 up from there. So you can draw it like that. Okay, so it's going to come across like this, and then it's going to start to go up. And this is g of x, which equals 2 to the x, and then I add 3. Key points, well, this we just said was 0, 4, and I suppose you could get another, I never quite turn mine sharply enough, but another point on there which we know is going to be 1, 5. Domain, x hasn't changed, so it is xer, so x is a real number. Range, range, well, now with the asymptote shifted up, that y has to be greater than 3. The minimum value, well, there is no minimum value of y specifically, but it doesn't go as low as 3. So range is y must be greater than 3, and the horizontal asymptote is y equals 3. Note that down because I think I might need to get rid of that. So now we're on C, and we are doing, so if f of x equals 2 to the x, well, minus 2 to the x, and minus 2 like that, well, we've basically multiplied this by minus 1, haven't we? So it must be minus f of x. And if this is outside the brackets, this special stretch, this is a reflection in the x-axis. In the x-axis. So what we need to do is, get this, we're using the x-axis as the invariant line, and we're going to have to sort of just mirror all of this about this mirror line. So this 0, 1 is going to have its equivalent point or its image point on the new graph of p of x is going to be at 0, minus 1, and so on. The asymptote's not going to change because this, when this y equals 0 line, the x-axis, that's fine. That is the invariant line, so that's not going to change. This 1, 2 is going to become 1 minus 2, so I'm going to draw the axis here and here. So it is going to go through 0, minus 1, going to come along like that, and then it's going to go down. So this is 0, minus 1, and we have a point on here which we just said was 1 minus 2. Again, we need those three things. We need domain, range, and a horizontal asymptote. So domain is still the same. Any x value you can put into this, you will get a y value out. So the domain is x is just a real number. Range is, well, here you have a maximum value of y. Well, you don't. You have a horizontal asymptote at 0, and y basically gets very close to 0, but it's always negative and it never gets to 0. So the range is y must always be less than 0 and can never be 0 because that's the asymptote. Okay, and then finally the horizontal asymptote. Asymptote is y equals 0. Okay, I reckon we'd just about be able to squeeze d on. So 2 to the power x minus 4. So if f of x equals 2 to the x, well then 2 to the x minus 4. Remember, we're changing the input. The function, the f, is to take 2, raise it to the power of something, right? So what we are doing, we're changing the something before we raise 2 to the power of it. We're messing with the input before we go ahead and perform the function. So this is something happening inside the bracket. It's happening on the argument of the function, the thing we're plugging in. And so this is f of x minus, sorry, f of x minus 4, like that. And this implies horizontal change because it's in the bracket. It kind of implies an inverse effect, so it does kind of the opposite of what you might be thinking because it's inside the bracket. And because it is an add or subtract, it implies it's a translation. So this is a translation, if we put it all together, and it's going to go 4 units to the right, and it's not going to move up at all. So if we look at that, we just take this graph here, this 0, 1 is going to be at 4, 1 all the way over here. This 1, 2 is going to be at 5, 2 over here. And everything's just going to kind of go from there, really. So it's going to be up something like that, and then it's going to get to its asymptote somewhere around here. So let me see if I can draw that. So it's a lot easier to do these when you actually just sketch, when you have the parent function already, but it's not what we've been asked to do. So actually I might just move that. Give myself a bit more room out there. X and y. So as I was saying, I kind of want this 0, 1 to be at 4, 1, so something like that, 4 across and 1 up, and then 5 across and 2 up, like that. And if we take everything else, it's sort of going to be quite low by the time it gets. What you could do, you could work out that y-intercept. I'm not going to bother, but you could, you know, it's going to be really close to 0, but it could be, if you really wanted to draw this nicely, it could be a good scalar. So okay, something like that. And this is r of x equals 2 to the x minus 4. And then all we need now is domain range and a horizontal asymptote. So domain unchanged, x is a real number, range is also unchanged, y is greater than 0, and the horizontal asymptote is unchanged too. Horizontal asymptote is still y equals 0. Okay, so it's quite a long one. Hopefully, I mean, we've done this anyway, really. Hopefully you know the principles anyway, but if not, then maybe this helps. I want underpin some of it.